Okay, ETAs. How long until I get to a certain location? This is just a long form version of 60D Street that we just went over, but it will be expanded on later once we go into really long distance ETAs, so I'm going to break this down in more detail. Imagine we're following this track line here. Obviously, none of this is to scale. We got 8 miles, 4 miles, a mile and a half, 30 miles. But we're trying to figure out how long until we get to here. Well, each one of these is a distance, and if you have your speed, which let's say we're going 15 knots in this problem, then you can just take your speed and your distance and you could find time. What you could do if you really wanted to is you could add all these distances up and then do the calculation there, and that will give you the exact time of arrival. By the way, this is starting at 0900, the exact time, estimated time of arrival at your last waypoint. But that's not very helpful because you would like to know when you should be at each of these. So the proper thing to do is to calculate your ETA to here, calculate your ETA to here, and then finally to here. And based off of each other, it should be mathematically the same as if you added them up. And if you want to check your work, you can add them up afterwards. But you do want to break it down to each waypoint. And if you want, you can set DR positions along each waypoint to be even more precise. That's always the proper thing to do. Now, let's start with the first leg here from our 0900 fix to waypoint 1. We're going 8 nautical miles at 15 knots. Okay. So we set up 60D Street. So 60 times 8 is equal to 15 times T. You don't necessarily need to do everything in your head. This isn't a very easy problem, so you can just use a calculator for that. Divide by 15, get 32 minutes. So it'll take 32 minutes to go 8 miles here. You add that onto the time of your original fix, and you could say that you're expecting to arrive at 0932. We'll get into proper plotting later, but technically an ETA or a DR position should be written horizontally, whereas a fix should be written vertically. Now, our next leg is 4 nautical miles. We could calculate this again. We could easily just write out 60 times 4 is equal to 15 times T, but what's the relationship here? We know it's going to take exactly half the amount of time that it took to go 8 nautical miles. And even though you don't need to, put down to memory that 8 nautical miles at 15 knots will always be 32 minutes, you could, knowing it right now, say, all right, well, what's half of that? 16? Yeah, 16. Okay, so it will now take 16 minutes to go this next leg. So add 16 on, you get 0948. Cool, that's our next leg. Now from 2 to 3 is 1.5 miles. What is it? 1.5 miles. That's 1/10 of 15. Oh, that's crazy. How long is it going to take you to go 1.5 miles at 15 knots? It's almost like we learned a rule for that. It's going to take exactly 6 minutes. So then you know this leg is 0952. Again, you don't have to do this in your head. You don't have to do this in your head. You can always write it out, and if you're unsure, you should always write it out. But you'll start to realize that this is really just my basic fractions, and if you have a good understanding of the speed you're doing, if it's consistent, you can always just transfer it between the two. Now for your next leg, 30 nautical miles. I'm going to write that one out. So 60 times 30 equals 15 times whatever length of time. 60 times 30, you get 1800 is equal to 15 times T. So you divide that by 15, you get 120. Remember, this is in minutes. All of these calculations are in minutes. So 120 minutes is what, 2 hours? When we get to distances like this, 30 nautical miles, that's when it's useful to switch from 60D Street to just D Street, because then you can calculate things in hours not more precisely, it's exactly as precise, but more conveniently. Anytime it's really going to take you more than an hour, that's probably the easier thing to do, but it's just as accurate. So it's going to take us 2 hours to go here. So from 0952, we should be arriving at waypoint 4 at 1152. Now, if you wanted, let's check our work. So from 0900 to 1152, 8 miles, 4 miles, 1.5 miles, 30 miles. We could add that all up and we get 12, 42, 43.5. So this whole track is a distance of 43.5 miles. If we do that in 60D Street, we could probably do D Street as well, but because we're trying to break this down into minutes already, it might be easier to do it this way, times 15. You get 60. You come out to 174 minutes. Subtract 120 to get, because that's the 2 hours of this one, we know that's easy, you can get 54 minutes. Oh, 6 minutes not. Okay, yeah, so I was just wrong here, where I added 4 minutes instead of 6 minutes. So yeah, that would get you plus 2 hours, and then plus 54 minutes would bring you to 1154. That's why you shouldn't always do things in your head.